While we provide custom EtherNet IP drive communication using our PLC Controlled Motion plugin for Connect software, many times people just want to perform simple drive to PLC communication without using add-on instructions. In this video, I'll go over what is required for basic EtherNet IP communications to one of our drives from an Allen Bradley PLC. I'll demonstrate how to use our Connect drive commissioning software to enable EtherNet IP communication, how to map drive parameters to EtherNet IP data words, how to add one of our SI Ethernet modules as a node on an Ethernet IP network, and how to access and modify drive parameters from within a PLC routine. So if you're ready, let's get started. The demonstration equipment that I'm using for this video is connected per the diagram above. As with any system that utilizes a communication field bus like Ethernet IP, care should be taken to ensure that you do not overload the network with unnecessarily high communication rates. We recommend that the RPI interval in the PLC be set to no less than 50 milliseconds for best results. Now let's open Connect software, and I'll start a project for the Commander C300 I'm using for this demonstration. I have Connect software open, and since I'm working with a new drive and a new SI Ethernet module, the first thing I'm going to need to do is use Connect software to assign an IP address to the SI Ethernet module. Now, that's pretty simple to do, but what you should understand is that the device discovery tool that's part of Connect is going to assign an IP address on the same subnet that I've assigned to my computer. So what I've done before I open Connect is I've gone in and I've assigned a static IP address to my computer that's compatible with the subnetwork that the machine is using. So in this case, the machine is using a subnetwork of 10.10.1, so I've assigned a static IP address to my computer of 10.10.1.200. So I'm going to start a new project now by scanning the Ethernet network. And here's the device discovery tool that I referred to. And as you can see, it's scanning for devices. Now, since everything is new, it's going to come up with this, saying that, yes, I found a device out there, which in this example is an SI Ethernet module, but it can't communicate to the computer because it has an incompatible IP address. So the first thing I'm going to do is click Configure. And here's what I was saying. Notice that it comes up with a 10.10.1 subnet. Well, that's because that's what I assigned to my computer. So I'm going to assign a static IP address of 20. The other thing that's nice about setting up the static IP on your computer to match the machine is that the device discovery tool will scan the network to make sure that there are no other devices already on this subnetwork with that last octet. So as you can see, that IP address is available. So I'll just go ahead and click Apply now. Okay, there's my Commander C300. So I'll click OK to start a new project. Now, since we're going to focus on the SI Ethernet and Ethernet IP communication, I'm not going to spend a lot of time going over the commissioning. There are lots of other videos and courses on our Learning Center that will show you how to do this. But what I am going to do is I'm going to configure the drive to use preset speed mode for the speed reference. That's probably the easiest way to control one of these Commander drives on an Ethernet IP network. Otherwise, you would have to utilize an analog card in your PLC, which will work fine, but for my example, I'm just going to use preset speed. So as you can see, I went online with the drive now, and I'm going to go over to the parameters, and I'm going to open up menu 0. All right, so I'm going to come down now, and the drive is configured in open loop mode, but parameter 5 is what determines the speed reference. Where's that going to come from? By default, it's analog velocity. Well, I'm going to drop that down, and I'm going to choose preset right there. So here are the preset references. This is one of the parameters that I'm going to be updating with the PLC. So the next thing I'm going to do is show you how to configure the SI EtherNet module. While this is meant to be a simple example, I feel it is important that I demonstrate what minimum parameters are required to control the drive using EtherNet IP. Specifically, here are the drive parameters that I intend to map to EtherNet IP data words. Drive healthy, which is menu 10, parameter 1. Drive active, which is menu 10, parameter 2. Run forward, which is menu 6, parameter 30. Run reverse, which is menu 6, parameter 32. Drive enable, which is menu 6, parameter 15. And preset reference 1, which is menu 1, parameter 21. Now let's look at how to set up the drive for Ethernet IP. I'm going to prepare the drive for Ethernet IP communications. To begin, I'm online with the drive. I prefer to do that so I don't forget to download my changes afterwards. If you aren't able to connect to the drive, you'll need to remember to download the changes you make to the project drive to the actual drive once you are able to connect to it. Ethernet IP settings are found here in the dashboard for the SI Ethernet module. So I'll click on that, and then I'll scroll down a bit. And here in the setup area, you'll see parameter listings. So I will click on that. And the way you read this is slot 1, menu 2, slot 1, menu 9, so on and so forth. So I'm going to begin right here in slot 1, menu 2. As an aside, I should point out, any parameters that are highlighted in light blue, like these guys, that means that they are changed from their default settings. The parameter I want to modify here in this menu is parameter 20, which is priority protocol. The SI Ethernet module supports Modbus TCP IP and Ethernet IP. And by default, each of those protocols is allocated a 5 millisecond time slice of processor time. Well, I'm not going to be using Modbus, so I'm going to drop the list down and just select Ethernet IP and make that the priority protocol. And in doing so, what that means is Ethernet IP now gets a 1 millisecond update interval from the processor as opposed to 5 milliseconds. So it'll be looked at a little more quickly. So that's the only parameter in this menu that I would like to change. So I'm going to close that menu. And now let's look at the Ethernet IP specific menus, which are menu 20, 21, and 22. Let's start with menu 20. Ethernet IP is enabled by default, which is right here at parameter 1. So if for some reason you come in here and that is not on, well, of course you want to make sure that's checked. The parameter I'm interested in this menu for the time being is parameter 11, RPI timeout action. And what this is used for is to determine how the drive is going to respond if there's a loss of communication to the PLC. By default, it's hold last, which means that the drive will simply retain the last update from the PLC and carry on running. I'm going to change that to trip instead. So what that's going to do is if there is a loss of communication, the drive is going to trip. You'll get a slot 1 error to indicate that there is a loss of communication to the PLC. This behavior should ideally be handled on the PLC side. The PLC being the network master, if you will, you should set the PLC code up in your routine to take care of any communication loss to any of the nodes on the network. But you can do that here at the drive side too. Now I'm going to be coming back to this. Once we do our mappings, we need to change the input and output object size in bytes. So I'm going to leave that menu open for the time being. I'll go back to the dashboard and let's look at input mappings first. The words in and out are relative to the PLC. So in mappings are things that the drive is sending to the PLC, and out mappings are from the PLC to the drive. So let's look at input mappings first. By default, you're given 2 parameters. The way you read the value column here is slot.menu.parameter. So this mapping is slot 0, which just indicates that this parameter comes from the drive, the host drive itself, not an option module in a slot somewhere. What I want to do is I want to change this to be drive healthy. That is menu 10, parameter 1. So I'll just change it like that. Then I want to change this to drive active. So I'll click here, and that's also in menu 10, and it's parameter 2. And you can see the comments update to reflect that. So those are the only 2 things I'm going to send to the PLC. Now, let's go back to the dashboard and let's adjust the output from the PLC to the drive. What I want to send, first of all, is run forward. Well, that's in menu 6, so I'll leave that, but it's parameter number 30. So I'm going to change that. I do want to send preset reference 1, but I want to keep these things in order. So the next thing I'm going to change this to make that menu 6, parameter 32, which is run reverse. And while I'm here, the next mapping is menu 6, parameter 15, which is software drive enable. Nothing to do with the safe torque off. But by mapping this, it gives the PLC the ability to disable the drive in the event of a trip or what have you. And now I'm going to put preset reference 1 back. That's menu 1, parameter 21. Like so. So we have 4 data words out of the PLC and 2 data words into the PLC. Now let's go back to menu 20 and adjust the input assembly size. I don't need to change that. There are 8 bits per byte. So I have 2 32-bit words, which is 64 bits, which is 8 bytes. However, the PLC is sending 4 data words, so I need to double this to 16 bytes, like so. That's all I need to do in terms of Ethernet IP mapping and configuration. But before we leave Connect, it's very important that you go into the Digital I/O menu now, right here. Menu 8, double click. Notice run forward and run reverse are here by default. Well, I'm going to be writing to these from the PLC, and you can't have it both ways. So I'm going to unmap those by just simply typing a 0 there and another 0 there. Now, anytime you make a change to anything in menu 6, 7, or 8, the drive needs to be reset in order for them to take effect. So I'm going to come up to the control ribbon and click reset. There we go. And then the last thing I'm going to do with Connect software, and this is very, very important, is I need to save those changes. So I'm going to save the parameters. And then finally, I'm going to update my project drive with those parameters. So I'm going to upload from drive. And now my project drive matches the actual drive. So that's all there is for the Connect software side. Now let's look at Studio 5000. I've created a new project for my controller, as you can see there, in Studio 5000 software. Now let's see what it's going to take to add the Commander C300 and the SI EtherNet module as a node on the EtherNet IP network. To do that, I'll begin by right-clicking on EtherNet, and I'll choose New Module. This will open up the hardware catalog, as you can see there. And clearly, we're not a native Allen Bradley device, so we are going to be added as a generic EtherNet module right there. So I'll click Create. And that brings up the new module properties, as you can see. The first thing I need to do is give it a name. Now, this name might seem insignificant, but that name will become the controller tag that will be used to store the data for the drive. So I'm going to call it C300 to keep it short. The data type, the COM format, is double integer. As I mentioned in the video, it's 32 bits. And then I need to point it at the IP address for the drive, which is 10.10.1.20. And over here in connection parameters, this is the most important part of all. This must match exactly how we have the drive configured. So input is going to be instance 100. Output is instance 101. It will be configuration 1. Now, the way I think of this is the PLC will input 2 data words from the drive active and drive healthy. And then the PLC in turn will output 4 data words to the drive. So I'll click OK. The only thing I'm going to change here is make that 50 milliseconds, as I also mentioned earlier in the video. And then I'm going to click Apply, and then OK. Now let's test this. Let's download this to the controller. There we go. Download. Yes. And there we go. That's what we want to see. Okay, next let's have a look at how to use the data coming to the controller and how to write back to the drive. I've created a sample routine that will demonstrate how to read and write to the C300 drive over Ethernet IP. But before I show you that, I wanted to show you what I did here in the tag editor. And basically what I did was I just came over and labeled or put some descriptions on the parameters that are coming from the drive to the controller, and then again from the controller out to the drive. It'll make it a lot easier once we get into the routine and you start adding contacts, coils, and things like that. So that's kind of a simple step. And now let's have a look at my routine. I'm online with the controller, as you can see. And what I've done here is I've just set up a rung here that's going to check to see if the drive is okay, which it is. But what I want to point out here is very important, and that is the fact that once you assign a drive parameter to be updated over Ethernet IP, you need to, in fact, update it over Ethernet IP. The tag will have a value of 0 initially, unless you come down and change it. And speaking of changing, the way you send numeric data down to the drive is in integer format, inclusive of the resolution of the parameter that you're writing to. So this is an example. I'm writing to the drive speed in hertz, which is menu 1, parameter 21. So I'm going to flip over to connect now, and let's have a look at that parameter so you can see what I'm talking about. So let's look here, and then I'll scroll down to parameter 21. There we go. So as you can see, this parameter has a resolution of 2 decimal places. So back in my routine, when I'm using the move instruction and sending 1500, that's interpreted by the drive as 15.00 hertz. So that's very important. So the other rungs here, just very simple, demonstrate how to run the drive. So the drive is enabled. That's the menu 6 parameter 15. So I'm going to come down now and toggle my simulated push buttons and run the motor. I've also got a rung down here that simulates a drive running pilot light. And this is the drive active that we mapped. So as you can see, it's running. And then to stop it, I'll toggle that bit again. And we'll test the reverse also. Drive's running again. So that is a very simple example of how to use Ethernet IP with our SI Ethernet module. Although we offer free and easy-to-use add-on instructions for our Allen Bradley PLC customers using our PLC Controlled Motion plugin for Connect software, oftentimes it is easier to use a simplified method of adding one of our drives to an Ethernet IP network. When mapping drive parameters in Connect software, remember to not only map your desired in and out parameters, but also that you must adjust the input and output assembly size in bytes to match the number of bytes that your mappings will consume. These parameters are found in slot 1, menu 20, parameter 20, and parameter 21. In the same manner, when you are configuring the connection parameters on the controller side, the assembly sizes you choose there must match what is set up in Connect software exactly to avoid communication errors. Thank you for watching, and more importantly, thank you for choosing Control Techniques.